Let's take a few minutes and work through some examples out of 5.3. And in 5.3, it sounds like we're going to be going backwards from what we've been doing. In the previous sections, we took z-values and found the probabilities of having a z that's less than a particular number. We were given sometimes a z-value and asked for an area either less or an area greater than that z-value, which we discussed corresponded to probability. In this section, we're going to be at times given the area and have to find the z-value. So for example, we might be told that the cumulative area to the left of a particular z-value is 0.8714. And they'll say, what z-value has that area to the left of it? And to do that, we'll need to look at our table. Now, keep in mind that our distribution is normal, it's symmetric. So if we have an area of 0.5, we have an area to the left of the middle is 0.5, to the right of the middle is 0.5. So if the area we're given is over 0.5, then our z-value has to be to the right of the mean. If our area to the left is less than 0.5, then we would have to have a z-value over here. Because again, to the left of the middle is half of our data. So we're going to be looking for a positive z-value because it's to the right of the mean. So let's pull up this table. And we want to find out which z-value has the closest, has an area as close to 0.8714 as possible. Now, it might be that this number is not exactly in the table. So if not, we're going to pick the z that is closest. If this is halfway between two numbers, then we're going to pick the z-value that would be halfway between. So let's see how close we can get to 0.8714. So here's 0.8708, here's 0.8729. This one is closest to 0.8714. So that corresponds to a z-value of 1.1, and then the next digit is 3. So 1.13. So that's how that's going to work. If we're given the area, we look at the inside of the table, and then we read to the outside to find the z-score. So let's move on and take a look at another one. So let's look at this one. Even though this is worded differently, it's the same type of problem. They want us to use the table to find the z-score that corresponds to the given percentile. So for this one, it says find the z-score that corresponds to the 82nd percentile. Now, if we remind ourselves what a percentile is, that's the location where 82% of the data is below that. So if you make at the 82nd percentile on a test, that means you made better than 82% of people. So if this is the middle, then 50% is on that side. So if 82% is to the left of our location, we have to be over here somewhere. Because this area to the left of our z has to be 82% or 0.82. That's what we mean by the 82nd percentile. So that corresponds to an area. It's a percentile, it's a probability, but that also corresponds to the area under the curve. So we have to find out what z-value has that. So if we go to a table, we're looking for an area of 0.82, so not a z value of 0.82, but we're looking where is the area of 0.82. So like for example here the area is 0.8133. Here the area is 0.8186. Here the area is 0.8212. So 0.82 would be in between these. This one is 12 10,000ths away from 0.82. If you subtracted this from 0.82, this one would be 14 10,000ths away. So this one is the one that's closer. So this area corresponds to 0.92. So that's the given z value. It corresponds to that percentile. For the next one they're going to give us a graph, and they're going to ask us to find the z-score that corresponds to the given area. So we have an area of 0.1469 to the left of our z. So let's copy that over. So our cumulative area, our area to the left of z, is that. So we're going to look up this area and find out what z corresponds to that. So we need to pull up the table. Let's see, I don't know if I have the table up yet, so let me pull that up real quickly. I'll be right back. Okay, so this table, this is the positive z values, and notice all of these areas are 0.5 or larger. Our area is 0.1469, so that's smaller than 0.5, so we need to go back to negative z values. So we have to find out which one of these is closest to our area of 0.1469. So we scroll down. Here are the 1.4s. Here's 1.469. So it's the negative 1.0, the first two digits, and then it's in this row, or this column. So 5 is the next digit. So negative 1.05. So that is the z value that corresponds to the given area. Now let's do this one. Let's find out what z value corresponds to this area. So our table deals with z values, or deals with areas that are to the left of our z. When we look up a z in our table, this is the area that is telling us. Well, that's not the area that we're given. We're given the area on the other side of our z value. But remember, these two areas add up to 1, so they're complements of each other. So if we want this area, we do 1 minus the area that we know. So 1 minus 0.0505. So the area to the left of our z is 0.9495. So that's the area to the left of the z value that we're trying to find. So we need to go to a table and find out for what z is the area 0.9495. And right here it is. Here is an area of 0.9495, so the z value is 1.64. So let's show that again. Here's 0.9495, so the z is, that's in the 1.6 row in the 04 column, so 1.64. So just knowing how to use the table. All right, so next, let's try to do this. This is a little bit trickier. says find the z-scores for which 88% of the distribution lies between negative z and z. So what is it saying? We have a normal distribution. Here's our mean, which is 0. And they say if we go from negative z to positive z, now we want the z's to be the same number. So the only difference is this one over here is going to be a positive, this one is going to be the same number but negative. So we're trying to find out between which two numbers is 88% of our data. In other words, we're looking for the middle 88% of the data. So if this is symmetric, and we're looking for the middle 88%, then half of that is going to be over here. So 44% or 0.44 is on this side. The other half of that will be on the other side. Also, let's make the observation that since this area and this area are the same, these two z values are equidistant from the mean. That's why we say these are going to be the same numbers, just one is positive, one's negative. They're the same distance right and left. So if we find one of these, then we've essentially found the other one. Now we can go about this in several different ways. Let's do it this way. We know that this area is 0.44. And while our distribution is not, or while our problem is not including everything over here, if we want to know this z value, we need a total area from here to the left. So we would also need to know all of this. So guess what? That is all, the purple is all the area to the left of the center, so that area is 0.5. So if we take all of this area and then this area, put them together, then the area to the left of that particular z value is 0.94. So if we're looking for the middle 88%, then to the left of this z value will be 94%. So we need to find out what z corresponds to having an area of 0.94 to the left. So we pull out our table, we search for an area of 0.94. So here are 9 3s, here's 9 4. Notice these are equidistant from 0.94. This one is 600, I'll say it right in a minute, 6 10,000ths more than 0.94. This is 6 10,000ths less than 0.94. So our z value is going to be halfway in between. So this one is 1.55. This one is 1.56. So halfway between 1.55 and 1.56 is 1.555. So that is the upper z value. This one is the same distance to the left, so that'll be negative 1.555. So between those z values, we'll have 88% of our data. All right, let's work through another example. So this one says that in a survey of women in a certain country, and it gives the age range for these women, the mean height is 66.4 inches with a standard deviation of 2.73. So let's write that down. The mean is 66.4. The standard deviation is 2.73 inches. And they will ask us several questions. Let's do this one first. What height represents the 95th percentile? So we're looking for the height. Find the height that goes with the 95th percentile. So we're assuming that this is a normal distribution. We know that for this distribution, the mean is 66.4 with a standard deviation of 2.73. Remember, we worked some problems earlier where we found the z-value that corresponded to a percentile. So if we're looking for the 95th percentile, we're looking for at what point is 95% of the data lower than that. So at the mean, 50% of the data is lower, so we're going to have to be over here somewhere if we're going to have 95% or 0.95 area to the left. Now, when we look up an area of 0.95, that's going to give us a z-value. Not an x value, but a z-value. So if we go to our table, we're looking for not a z of 0.95, we're looking for an area of 0.95. So we want to find out where do we have an area of 0.95. So here's 0.9505, here's 0.9495. 0.95 is halfway in between these. So here's 1.6. So halfway between 1.64 and 1.65. Halfway between 1.64 and 1.65. So if you're not sure how I got the halfway point between those earlier, you can just average them. Add them together and take that answer and divide it by 2. And when you do that, you'll get a z of 1.645. So that is the z-value that goes with the 95th percentile, but that's not what we're asked. We're asked for the height. So we're looking for the x value that corresponds to that. But remember, we have a relationship between z-values and x values. A z-value is always the x value minus the mean divided by the standard deviation. So if we know the z-value, and we know the mean, and we know the standard deviation, then the only thing that we don't know is the x value we're trying to find. This is just a simple linear equation. We're plugging into our formula the things we know, and then we're going to solve for our unknown. So we want to get rid of the fraction. So multiply both sides by 2.73. So the 2.73 on bottom and top cancel, leaving x minus 66.4. On the left side, when we multiply those, 2.73 times 1.645, we get 4.49. Let's go to 3 decimal places, 4.491. So we're solving for x, so add 66.4 to both sides. Those cancel. So our value that we're looking for is 66.4 plus 4.491. So about 70.891. So that is the height at which 95% of women are that height or lower or shorter. So if you're 70 inches tall, then you're in the 95th percentile. Then part B of this question asks for what height goes with the first quartile. And remember that the first quartile is the same as the 25th percentile. So we would be looking at what height is 25% of the data to the left. So where do we have an area of 0.25 to the left? Notice I put this on the left side of the mean because if it was on the right side of the mean, it would have more than 50%. So if our area to the left is less than 50%, it has to be over here somewhere. So we can look up this area in our table, and that'll give us Z. And once we get that Z, we can find the X that goes with it by using our formula. Let's do maybe one more. So here's another example. The weights of bags of baby carrots are normally distributed. So if we're manufacturing and we're putting baby carrots in bags, we're told that their weights are normally distributed. The average weight, or the mean weight, is 29 ounces, and the standard deviation for their weights is 0.37 ounces. So then we're told bags in the upper 4.5% are too heavy and must be repackaged. So if bags weigh too much, then that presents a problem, and they're going to have to empty the bags and try again. So we're looking at the upper 4.5%. That's a fancy way of saying at what point, at what location is 4.5% of the data there or higher. So this area is the upper 4.5%. Well, let's convert that into a decimal. If we have 4.5% and we're changing to a decimal, we need to move our decimal places 2 places to the left. So that area is 0.045. So the upper 4.5% has an area of 0.045 to the right. Well, our table deals with area to the left, so we need the complement. So 1 minus that will give us how much area is to the left. 1 minus 0.045, 0.955 is the area to the left of this value. So that's the value we're looking for. What weight has this area above it, that area below it? So when we look up this area, it's going to give us a corresponding Z value. So we go to our table, and we look up an area of 0.955. So here's 0.95. Here's 0.9545. Here's 0.9554. We're looking for 955. So this one is the closest to 0.955. So that's 1.70. That is the Z value that corresponds to this area being to the left of it. And if we know a Z, the mean and the standard deviation, we can use that to find out our X. Z is our X value minus the mean divided by the standard deviation. So if we know Z is 1.70, we're trying to find X. We're told the mean is 29 and the standard deviation is 0.37. So as we did on the last problem, we just solve for X. To get rid of something on the bottom, the opposite of dividing is to multiply. So 0.37 on bottom and top cancel. If we multiply the left side by 0.37, we have 0.37 times 1.70, so 0.629. If we add 29 to both sides, that's the opposite of subtracting, so that'll make that go away. So x will be whatever we get when we add those together. So 29 plus 0.629, 20.629 ounces. So according to our description, if a bag of carrots weighs more than 29.629, then it'll be in the upper 4.5%, and it's going to have to be repackaged.